Okay. I think it might be working. Well, we have 31 people waiting on the YouTube link. Let's see. Cool. Hey, Brian. Hi, everyone. Thank you so much for taking time out of the Saturday to join us today. Let me just start real quick. So, I want you like let people. Right. I think we're just waiting for people to come in. I think everyone is here. Almost everyone. Nice. Oh, I need to enable screen sharing. How do I do that? How do I enable screen share? Um, so who is presenting? Is that Vern? Oh,
Yeah, I'm presenting first.
okay, good.
So I'll be controlling the presentation. So I mean, I'm the only one who needs the screen sharing or control. Oh yeah, poll too. Andre needs poll.
Yeah. So yeah, I made Vern and Andre co-host. So you should be able to do stuff on Zoom now.
Okay, well, let me try.
Yeah. Um, cool. I think we have people on YouTube as well. Hi, everyone on YouTube. Well, I see the chat on YouTube pretty active. Okay, before we start, I just want to like say hi. So a lot of I was on a call with a few of my friends yesterday, and they were like, "Why are you doing this book club?" Because clearly I'm not reading my own book. So the reason it started was pretty informal. I saw a bunch of people on our Discord saying it's like, "Is anybody else reading the book? Can I join a book club?" And it was like, "Okay, let's just make a book club." So honestly, I think it's just really how it started. But then I also realized I also enjoyed bringing people together. So I hope that through this we can just like meet and hang out and we can do stuff together in the future. So for people who are not in the book club, or like not in the core book club, so we divide into group, and each group will present about a chapter. Um, this is not this is not a summary of a chapter. So following along this book club is not a replacement of reading the book. So we I think that a book club works best, or any paper club. I have been part of several ones. It only really works when people actually do the reading themselves, and the meeting is best as a place of discussions. No, okay, so for the first chapter, we have group one who will be presenting on overview of machine learning system design. We're gonna have a little bit of summary, but then I'm really interested in like learning more about like your take on the topic. For example, like any experience you can draw from the industry, and especially we can't ignore that ChatGPT Claude, like all the really fun stuff happening with generative AI. And I'm just very interested in like what people think like how the machine learning systems is going to change with generative AI. So yeah, let's have with that. Please take it away. Chat Shap LP. LP is a
Yep.
great name.
Yeah, that's right. Okay, so thanks, Chip, for setting up the whole book club, and honored to be presenting to the actual author. So, all right, so just a quick check. Everyone can see my shared screen, the presentation.
Yeah.
All right, cool. All right, so this is cohort one, group one, Chad Shep LV. All right, so hi, this is Vern, and we are group one, aka Chad Shep LV. We'll be presenting on chapter one, the overview of ML systems. So our group name is a lazy pun on ChatGPT. SHAP LV is both an anagram of our names and an important concept in machine learning model interpretability. So it's the Shapley value. Here's our mascot, the Shapely Chad, courtesy of DALL-E 3 and Copilot. The input prompt was, you're an amazing AR artist. Please draw me a picture of a group of Shapely Chads who work in machine learning. So the output is a bit off in accuracy, but you can see it's not as ripped as we are, but it's close enough. So I hand it off to Shivam, who will start the team introductions.
Yep. Hello, everyone. I'm Shivam. I'm a senior data scientist at 3. I am working on building end-to-end scalable personalization systems at 3. Off to Harpreet.
Oh, Harpreet is not here today, unfortunately, but I will speak on his behalf. Harpreet is a hacker in residence at Voxel 51. He's got an immense following on LinkedIn and presumably as well Twitter. He is writing a book on RAG and also teaching a LinkedIn learning course on the same subject. So that is Harpreet. Moving on to myself, I'm Andre. I am a founding software engineer at Llama Index, where we are looking to build the data infrastructure layer for everything having to do with context augmentation, most notably at this point in time, RAG. Before joining Llama Index, I was at other startups, but also did too much schooling and got a PhD in probability and stats. Passing it off to Prakul.
Hi everyone, I'm Prakul. I am a product manager working with MongoDB. So I focus on AI ML infrastructure and platform mostly. So currently I'm working on vector databases, RAG architecture models, and these are LLM orchestration frameworks that you would use to put together embeddings and generative models with the vector database. And passing it on, the next slide.
All right. So unfortunately, we weren't able to get in contact with our team member, Louis Van Gopal, but we'll just leave a placeholder for him, if nothing other than just making our dumb mascot joke possible. But I'm Bern. I spent most of my time in my career in hardware, working at Broadcom designing Bluetooth chips. So if you had any Bluetooth connection issues with the Nintendo Wii or Apple Magic Mouse, then my bad. I didn't transition into nagging engineers into designing smartphone chips as a PM. Got acquired by Intel, did the part-time OMS CS degree while I was there, around the same time that the Rexus guru Eugene Yan did it, and then went back to being a software engineer messing around with TensorFlow in the 5G group. Then my group was sold off to Apple, and I got an MBA. So here's the agenda. So we will go over quickly the chapter summary and key takeaways. Next, what surprised you about the chapter? Maybe not so much surprises, but we'll have a poll for you guys. Related examples and case studies, and finally wrap up with what's changed with Gen AI. So maybe Chip is crowdsourcing second edition ideas here with us, and talk about what has
Not
remained the
me.
same.
I
All
feel
right.
like as a author, I feel like it's a failure if people read and no surprise. This means that I don't say anything original. But anyway, please continue.
But it is chapter one, and then most of us are, I guess, experienced ML practitioners. So first of all, as a former PM, I love roadmaps. So I love the graphic on the right that Chip put in that shows the roadmap for the whole book and how it relates to the different components of the ML system. So it includes the external factors of requirements, which is the focus of chapter 1 and 2, and then the users, chapter 11. So next week, we'll finish up the business requirements and then move on to data. Okay, so since everyone on the call has read chapter 1 already, this will be a quick recap. The book starts off by defining machine learning and all the parts needed to pursue a ML solution to a business problem. Then it goes into various ML use cases, recommender systems, predictive text, machine learning translation, and personal assistants, which may or may not have been, actually they have been, impacted by Gen AI. And next, Chip makes a point that currently most of the value add in machine learning solutions is more in enterprise than in consumer. For example, customer insights, process automation, retention, fraud detection, churn prediction, brand monitoring. It's all about acquiring and keeping your customers locked into your service. Though with Gen AI, perhaps consumer ML applications will experience a boost in value add, especially in the creator economy, like automated video generation, voice narration, and music. The last two sections in the chapter go over the differences between ML research and ML production and the differences between ML and traditional software development. So key takeaway 1, ML, what is it good for? The saying goes that if you're a hammer, everything looks like a nail to you. Similarly, if you're MLE, everything looks like an ML problem to you. However, there are real significant costs into pursuing an ML solution. The most extreme example is Stability AI, who spent about $99 million just on compute in 2023. And now the startup's viability is in serious doubt. So before you jump into Jupyter and start running and evaluating models and data, make sure that your business problem necessitates an ML solution. A good rule of thumb is to make sure it satisfies most, if not all, of the requirements that Chip laid out in our definition of ML. The answer to what is ML good for? Otherwise, you get a suboptimal solution like that round peg in the square hole. Since you read the chapter, you should know this 9-part definition by heart, and that each part was broken down and explained in depth. I will call out number 7, so the cheap cost of wrong predictions. It is hard to ensure that, more on this later. So a hint is, take a look at our Chad mascot. It wasn't generated by Gemini. So key takeaway 2, ML, keeping it real. The biggest difference between academia and industry is that as an ML academic, you don't have to deal with business objectives and technical constraints set forth by various stakeholders, such as execs, sales, marketing, product, the backend team. Here's an example. So what if you have two high-performing Rexus models or recommendation system models, but what if they can't return the recommendations within 100 milliseconds, a product requirement set by the PM? Then you can't use them. Another difference, from the picture, you can see that Andre Karpathy spent about most of his time in Stanford worrying about the models and algos, and only a little bit about the data sets. Whereas at Tesla, he worried about 75% on data sets and 25% on the models and algos. Similarly, in academia, you're iterating quickly on model development, so training speed is prioritized. Whereas in industry, models are trained less frequently, because they're bigger and more expensive to train. And model inference speed is prioritized. In academia, when you serve the model, you care more about increasing the throughput of samples processed, so there's a bias toward batch processing, versus optimizing for lower latency in how long each sample is processed. And in academia, unless you're specifically researching AI ethics, you probably care less about fairness and interpretability than politicians or stakeholders looking for a reason to spank a tech company. So in the interest of time, I will skip over the differences in ML and traditional software development, but it's interesting to compare what are the local GPU VRAM requirements of the most taxing 3D computer games versus one of the smaller LLM models. You can see below, and you can click on the links for more comparisons. Okay, key takeaway 3. So enterprise better than consumer for classical ML? Yeah, maybe. But currently, there are more established profitable use cases in ML in the enterprise space versus the consumer space. However, Gen AI might be changing the game with new applications and tools for creatives or content producers in image, video, and music. You can see that news headline there about Tyler Perry's freakout about Sora. So now, while ML solutions should have a cheap cost of wrong predictions, according to Chip's definition, in practice, it's kind of hard to mitigate the monetary downside. For example, here are cases of both enterprise and consumer flops. Zillow's regression model for pricing homes caused a loss of more than $500 million in the real estate speculation efforts, leading them to lay off more than 25% of their workforce. And more recently, Gemini caused a $70 billion drop in market cap for their company, Google, because of issues of fairness. Who could have predicted that? Don't say ChatGPT. Anyway, that's the reason why I can use Gemini to draw our Chad mascot. It is disabled from drawing people for the time being. Now I hand it off to Andre for any surprises and a quick poll.
Can I just jump in? I want to just jump in with a few things about the point we just talked about. So one thing is just like for the use case, when I wrote the book, indeed was just like enterprise use cases dominated, and I do think that one a reason is that because back then there was not a ready-made model, so the only people who could like if you want to build applications, you just need to build your own models, and the only people who could afford to build models were with data and resources. But nowadays models are readily available, so I'm seeing a lot of really great B2C use cases for in AI. And also another fun fact about the example on the, I know that it has an example of like Andre Kapathis on the amount of time he spent on data. So Andre actually came to our class one day and shares a story of like when he wanted labeling, he needed a labeling team in-house. And when the HR team was asking, okay, send, how long do you need labeling team for? And he was like, how long do you need engineering team for? Just to say how important labeling is. And it's just after that, like a few months after the book came out, actually Tessa led off the labeling team. And it's just like, oh my God, this is really sad. But okay, go on.
All right, take it away, Andre.
Great, thanks. Yeah, so this section is meant to be on what surprises about the chapter. And so we don't really have surprise a slide here for this other than a poll, but I will touch upon, my surprises if I sort of put myself back to, when I first came out of academia. So I will speak on this a little bit on slide 15. But in the meantime, I will run a poll, which I will allude to the results again when I talk about slide 15. Oh, perfect. Thank you. I think, Chip, you ran it for us. Great. So essentially, yeah, we're just trying to gauge your experience with ML as you are currently reading this book. Just give a couple minutes. Oh, interesting. It's pretty cool to see the percentages sort of dance around here. Looks like more than half have developed products in market. We've got 3% of folks, so still significant, that are brand new-ish to ML, and 14% that has some experience in building ML solutions, and then 24% research projects in academia. Okay, cool. So we still have, this group is not random. Okay, Chip carefully selected this group. Nice. Okay, great. So I think, when I again go back to slide 15, talking about my own sort of experiences coming from academia to the industry, then I think at least 26% of you hopefully can relate. And then for the rest of you, hopefully just offers a different perspective on the matter. Awesome. I think at this point, what we'll do is we'll move on to the next section, Vern, which is case studies, and Shivam will take the mic.
Yeah, thanks. Thanks, Andre. Cool. I guess since 58% of us are already aware of the ML systems, I'm guessing for most of them, this will be something familiar, but still for the rest of the people, I'll sort of show, I'm like, objective is to connect whatever Chip has mentioned in the chapter with with an application in industry, right? While we look at, and that application is Rexes. So while we look at Rexes from the point of view that, yes, we'll do collab filtering or some two-tower architecture and we're done with recommendation system, it's not as simple as that. Recommendation systems are as data science heavy as they're engineering heavy, right? So they go hand in hand. And through this sort of these next 2-3 slides, I am going to show how that part comes into the play and how that connects with what Chip has mentioned, right? So this first slide is core ML, core DS part of the things, right? You prepare data, which in itself is a very important part, right? Because what goes in that comes out. Then you create models. Based on those models, then you do some recommendations. Now, if you look at a Rex's system, it's not just ranking, like it's a combination of two systems, retrieval and ranking. And both retrieval and ranking have their own set of challenges, which we have to deal with. Retrieval being high on recall and ranking being high on precision. Then, of course, because we are solving this problem for a business, so things come back to us when we are also trying to bake in business objectives. Like I want to keep the ads revenue constant, or I want to introduce fairness or diversity, like Spotify, right? And of course, you will only choose the winner model based on metrics and evaluation, and that too just offline. Offline will give you a winner model, but if you want to go to prod, you have to do some sort of A/B testing. Um, so this is just the ML part, right? Here itself, you can see parallels between, let's say, LLM based applications where uh, retrieval is the part that works there in RAG systems, right? Retrieval augmented generation. So you can see that these are the components which come together and build the access as a whole, but not like you can't ignore one part and work on just the other part. Next slide, please. Cool. So we have covered the data science part, which most of us try to focus on. Now comes the part which revolves around the whole ML data science parts, which are the super important parts of it, which make or break the access, right? So you've built the model. Now, how do you serve that model? Of course, you have done all the offline tests. You know that this is a winning model, but online is the part where it all shines through, right? Request comes in, how quick, how throughput, like how fast are you in embedding that query through your model and getting the top K candidates through your approx and an index, right? And it may not be just approx, and there could be some other candidate generator model based on which you're retrieving top n items or you're selecting top n items. Then so this is the retrieval part. Now for ranking part, of course, you have to figure out what are the features, how do you merge those features real time, or do you do offline? Then you have to decide where these features are residing. Some key value database like Redis or DynamoDB. Then once you join the features online, then you rank them. Here also, the latency throughput matters, right? Because the bigger your model is, the longer it's going to take to do any sort of inference, and thus it's going to take longer to arrive at the result. And of course, Chip has covered this in the chapter also. For any product, for any consumer based application, it matters how fast you are when you're showing the results, right? So even like 10 milliseconds, 20 milliseconds, 100 milliseconds, like even though as humans we don't really look at milliseconds level details, for a product, for an application, that sort of latency matters, right? So all of these decisions, they come into the picture. And then the observability part, which is the third point in the slide, where you of now you have settled everything, you have deployed your models at scale, it's working well, but how are you able to debug? How are you able to figure out that it's going to like it's working well throughout the time, right? Then you will look at how you're logging. Now, let's say your product manager or someone like leader in your company comes and asks you, why is he seeing this particular ranking, right? It's very hard to tell that person that because model is behaving like this, that's why. Like you have to dig deep, you have to find out that this is the feature which is relevant for this person, hence this is coming at the top, or hence this is not there. So all of this require logging. Then you have to be able to debug RCA, check job failures, error rates, all of those, right? So this is the production, like MLOps part of the view, which we like most of us don't consider when we are just looking at Rex's applications, but this is one of the core parts that make Rex's work. One next slide, please. And this is the extended version, right? So now you have created a model, you have deployed it. How do you keep updating it? of course, it isn't going to keep updating itself, right? Every day you're getting new data. Every day, based on your recommendation system, you're sort of creating shaping one set of distribution for users. Users are downloading, not downloading, user are ordering, or user are going through content. So your data distribution keeps changing, right? Feature distribution also keeps changing. Maybe the dependency between features and your actual prediction variable also is changing. So to keep up with that sort of changing trend, you have to keep your model, keep your system retrained. And that applies to both retrieval part and ranking part. And of course, the whole set of things that you did from offline till online, you have to keep doing it till your product is there, right? So this is advanced part of ML engineering view, which of course you have to take care of. But once you have figured out, you've captured the basics. Yeah, I hope this connected whatever Chip has covered through throughout the chapter. Um, Feel free to ask questions at the end of the year. Off
I'm
to yeah, sorry, Chip.
I love what you said about the extended versions of retraining, because I think that's a big question people are asking about, like how to get big models like GPT to be able to update with like more real time informations. And I think that in a way like RAG can help with that, like assuming that like you can provide with new informations and it can input it as a context. But I think I would love to hear more in the discussions. And also like there's an active discussion going on Zooms about the compute advantage, because that example of like Stability AI like spent a lot of money on compute. And from my impression, like, when they were raising money like about a couple of years ago, it was actually the competitive advantage, because it was during the GPU shortage, and it was just like, oh, we have access to like an abnormal amount of GPUs compared to other startups. So things been changed, of course, as we like the shortage become less of a shortage. Sorry, I can't say the word. Yeah, so I also saw that's like people were talking about like a certain like we see a lot of companies that like as a compute or like inference AI, they actually provide, or like even web dev, they follow this model of like they connect users with the GPU providers, GPU clouds. So they let users access to compute like per hour very cheaply. And I'm still wondering like what is the business model here, because it's like basically it's a middleman, but like for how long do we still need middleman for that? But anyway, yes, please go on.
Cool. Okay, and I'm going to speak on behalf of Harpreet on this slide here. And as we were having our group discussion, group one, that is, I think Harpreet made a good mention that I think this piece might have been perhaps missing in chapter one on evals. And so, there are definitely striking differences on evals between academia and research, where in academia, you're looking at loss functions, and Harpreet has noted it's like researchers BFF, and production's frenemy, which I definitely think is true. And I think Chip also alluded to that in a little bit with respect to the benchmarks that researchers always, obsess over to a certain degree. Oh, yeah, that's actually point two. Benchmarks, great for controlled experiments, but yeah, not for real world, chaos, which is, a lot of data noise, and just a lot of noise, not even with the data, but with like the whole management and people as well. And the last point that Harpreet made mention here is production means. So noisy data, did the data distribution shifts and custom metrics, all of these make it super challenging to evaluate your ML system in production in the industry versus like academia, where you're kind of in a toy setting. Everything is controlled and things are nicely done for you. I believe this is all Harpreet wanted to mention. I don't know if anyone else in the group wanted to top up there. But if not, I can move on. And so this slide here, I kind of want to take a step back, and it was awesome to read Chip's chapter one for me personally, just because, as a group, we were again discussing, what were the surprises for us, and like we all sort of immediately said, yeah, no surprises. And sort of Vern was just like, hit the nail on the head. We're all very experienced ML practitioners at this point. But as I thought about some more, and as I read a couple more, reread the chapter 1 a bit, I remember the quote that Chip said, essentially about, if you're like coming from ML academia, I'm paraphrasing here, then this chapter is probably more beneficial for you, right? And so I thought about that and said, okay, if I project myself back into when I was first coming back into the industry from academia, is everything sort of resonating with me? And from the benefit of hindsight, I definitely think all the points and themes that Chip outlined in this chapter are spot on. And so what I'd like to offer are like my own personal experiences when I was coming from academia into the industry. So on the left-hand side, I've got my before, and now like in the right-hand side, I've got the things I've learned so far. So the first theme, essentially is the model is the end all be all. And that's what I thought of essentially coming in to the industry. Do a kick-ass model and it will be the best, and the company is going to go and succeed. And Shivam has also showed in his previous slides that there's way more, especially from the engineering perspective, that goes into making an ML system or ML application be successful. I will also offer the importance of alignment, which I realize, and essentially, this being a cross-disciplinary thing, launching and having an ML system succeed, you've got various stakeholders with different objectives, which are at times competing with one another. And if you don't have alignment, and I've seen this happen before in my past experiences, then your ML or data science journey, or sorry, application is pretty much like lost right from the onset. And what I mean by alignment is essentially if, say, for example, business folks or tech folks are not aligned as to the success criteria of the ML solution, right? Or they're not aligned as to what can actually be done with an ML, right? Sometimes you can get into a situation where ML can be viewed, and you kind of get this with LLMs today, though they are powerful, can be viewed as a magic wand that achieves everything. And that's simply not the case. And so I know now, like, the model and the algorithm are just small parts of the of the whole ML system. Oh, sorry, there's one other thing I do want to make mention. There's definitely some personalities that you need to deal with as well at some times, especially if the system that you're about to implement, say, in a client, with a client, is replacing a sort of business as usual or an existing solution. And if the folks there who have been running that solution for 10 plus years and have really built trust with that solution, you're going to have to fight the battle of personalities and change management and getting them to buy into your AI ML solution. So I think that's a little bit of part of alignment. And if you don't have that, then I don't think you get even to the technical fun stuff. And the second theme here is, like, I scoffed at measurement and maintenance, and I sort of alluded to this in the previous slide that Harpreet prepared. But one thing that I learned in my past experience is, like, I wouldn't bother with creating an ML system if I know that the environment is not amenable to measuring the system appropriately. I've been in situations where, like, the ground truth of data is ground truth of the ML application is mixed. You've got two two sources of ground truth, or you're using a proxy to measure the objective function. All of these misalignments, I think, are get you yourself shooting in the foot, sort of thing. And so essentially, measurement and model maintenance are definitely things not to be scoffed at and things to be taken a little bit more serious. And as an academic coming into the industry for the first time, that's definitely not something I thought of. And the last thing is, like, as an academic, and I still have these academic tendencies, I just wanted to use the latest and greatest. So, like, if there was a fully functional ML system, I didn't really care coming in. I was like, I just want to use this algorithm. I want to use this code base. And I had to sort of reshift my paradigm, I guess, personal paradigm in a way to sort of accept that, perfection is not really the way to go. There are way more suitable methods that that exists, and it might not be a machine learning one, as Chip mentioned in her book. So yeah, this is just me drawing from my own experiences. So like this could have fit in under surprises, and I could have been like a retro on this. But I think, there's about 28% of us here, or 26%, that are academics, and hopefully, what I mentioned here sort of is relatable.
So there's a questions on YouTube about like what do you mean when you say the training loss is a frenemy of production?
The training loss is a frenemy of production.
Yeah,
Yeah,
loss functions. Yeah.
I want to think of that from. I'm trying to think of how Harpreet would have thought about it, because that was his slide. I guess the way I would interpret it is, I don't know, and this could be way off here, is, train, and you alluded to this in your book chapter. In academia, you care about training, right? And so it's more about the training loss, whereas in when you're productionizing an ML system, you care more about inference, but there could be other metrics that you care about, which is like maybe that training loss, you need to somehow calculate a dollar figure amount, an expected value to, some sort of revenue or something like that. And so the training loss might be the end all be all for the academics, but when you go into production, you need to get down to a bottom line. And so it's not, if you sort of focus on just that loss, then you are probably not moving the needle on the things that the business actually needs to move on. That's
Yeah.
probably how I interpret it, but I could be wrong here.
I actually been thinking about it because also like for language modeling, right? I'm not sure you're familiar with the loss function people use using it cross entropy, or also variations like perplexity. And it turns out it's like I think it's like it's pretty good to indicate how good the model is at like capturing the training data. However, you can see like you can see this like for if your model has gone through post training. For example, you do like supervised fine tuning or like IOHF, the perplexity numbers actually change a lot. So we like actually like so you can't really look at the perplexity of a post-trained model to determine how good it is. And I think that for that, also like the perplexity for training also it helps you learn certain things. Like it have you understanding how good the model is at like completions. Like okay, you give it a text, how it continue, but it doesn't really captures like how good the model is actually on downstream task. So I feel like there's still a gap between like the training functions, the loss functions, and the application's objectives. And sometimes you can use the loss functions loss value to like infer, but a lot of time it's just like a very not really accurate proxy.
Yeah, that's a good point.
Uh, Many times also, it's also the perspective of productionization, right? For example, a very concrete example is I've seen in research papers excess loss functions being listwise and pairwise, whereas I've seen very few of them in production, because if you're trying to implement listwise, your whole infra needs to send the whole payload to your inference model and then do it on batch, which then comes back to your compute sort of trade-off, right? So even from that perspective, very complex loss functions are hard to productionize, which could also be another point towards loss functions being frenemies.
That is a very good
That's a good
point.
point. Yeah.
I also like think the benchmarks, and I think that's like benchmark has always been an issue like 2 years ago, but now it's like even crazier. So I'm thinking is just like I think there's a reason why like benchmark or evaluation getting so hard is that like one before like, you train the own model, so you have a lot of understanding of how model is built, like it help you evaluate better. But now you can only like do evaluations from the output of the model. And another is that because now the model is open ended, right? Like the responses, I think like models can just output anything, which is a good thing because it means that you can use models for a lot of tasks now. But at the same time, it makes it really hard to evaluate. So a lot of people try to use like closed-ended tasks like multiple choice question to approximate how good a model is. but it's just like you're trying to capture something open-ended with like some close-ended evaluations. And also another thing is just like so but in the past you built model for a specific task, so you know what you want to evaluate the model on, but now you're trying to capture the general intelligence of the model. So benchmark are not just about trying to see like if the model is good in the task X, but also trying to like um discover like what tasks the models can also be good at. And also like we have benchmarks that get saturated all the time. Like you launch a new benchmark and like a few months later, so it was like, oh, good, perfect score on it, and you just keep on like it's like chasing a moving goalpost.
Yeah, and it's not an indication that of success in production, right? So most of the time, I think definitely companies will benefit from creating their own internal benchmarks on their own internal data sets. But I don't know if that's something that companies have traditionally invested time and focus on. Cool. I think it's now on to Prakul.
So I think Chip touched on this a little bit in the beginning, where like things have changed in the past. So how in earlier with a lot of the use cases, you had to have large amount of data. You need to have a lot of like labeling capability, where like what is a good response, a bad response, which require a lot of humans in the loop, and then you would have a lot of compute power and algorithm that you would want to test out, train things. And that's typically was a basic process of getting into getting like a few test candidate samples. So that's something that's changed in a big way in generative AI, right? So for me, I was previously in self-driving space, and over there, like for every single use case that we are building, we are typically going for a deep learning use case. So it's a camera model, it's a LiDAR, it's a radar-based models. All of those are pretty expensive use case for any small thing that you want to do. So we just wanted to talk about what changed there, right? So like just as a brief, like I thought this visual was pretty encapsulating of that. Like, we are kind of moving, even though like the name generative AI does exist, it is not necessarily like a complete autopilot. Now that's was one thing. It's still a subset of the complete scope of discriminative AI. It is still a very good pattern recognition machine. So for context, like, we're looking at ChatGPT, and ChatGPT is able to like, ask, given a certain question, it can give you a lot of these answers. You can use it as a classification model by some prompt engineering, the underlying foundation model, um, as well as doing a lot of like mathematical and reasoning kind of test cases. But I think one big piece there is it's still trained. It still uses the same methodology trained on a bunch of data sets. Just the kind of methodologies and downstream applications have just increased a lot. So what does it mean for us? The next slide, please, on that. So I think one thing that's kind of that's leading to is this democratization of AI. And that's where we think like, a lot of people are going to be starting to use AI in their softwares and their application just to solve a specific business problem that they're trying to go for. And the reason for this is availability of these foundational models. So these are in variety of domains. So you have like, the most popular ones are the text-based large language models. So on the image on the right talks about some popular models. So it's an old image. OpenAI GPT-3 was a popular model. There are few from Cohere, Anthropic. There are a lot of the open source ones. Mistrals have caught on. And with this, like, you as an application developer, you as an engineer can go off and start building a lot of applications directly, right? Like, so if you had to do a support kind of a use case where you could be in the loop with a human to provide assistance in a chat or an email setting, um, earlier it would have required a lot of data set collection. Now it's just about making a call to a model and taking iteratively from there. You may want to do some fine tuning. You may want to do some other methodologies like retrieval augmented generation, some prompting, but that's how you go in. So super exciting time, I would say, like, just for the ML community in general. And like, we are seeing these amazing use cases across coding ability, or images, speech, video, 3D. So all of these different domains are going to be accelerated, right? So that's where we see every engineer becomes an AI engineer, sort of a just written in a little bit of a large scale setup, but like, it's more about like you would require some capabilities like evals, benchmarking, capabilities that were required before, like, people, and you need those capabilities also in this new world. And so in certain domains, it's important to accelerate the path, but we want to use the best practices and set up from the previous domain into this new tooling world. And yeah, I think we can go to the next slide.
Cool. And so in this one, I just wanted to, I guess this is sort of offering not an opposing view, but also, and hopefully not a wet blanket to Gen AI. But it was definitely something that was a realization I had, especially because, in the company I work at, we work super fast and like bringing out the latest and greatest with RAG or any sort of context augmentation application. And I do get the opportunity at times to present to, companies, and a lot of companies that don't necessarily use LLMs to the degree at which I have used them. And so this slide is about trust in Gen AI, and is trying to contrast the trust that was, afforded to the ML systems. And I think mostly it remains the same, but I think also generally that trust in Gen AI is not going to be a step function. It's going to be something that we will need to work on. And so here's a quote that is from Chip's chapter 1. While most of us are comfortable with using a microwave without understanding how it works, many don't feel the same way about AI yet. And this sort of resonated a lot with me when I recently gave a talk to an investment firm that they do have a data science arm, but it's very small in comparison to the rest of the company. And I showed this example of using an LLM to extract fields from PDF. And it was like magic, where you just prompt the LLM like, hey, I need to get the CEO, COO, investors, and spit it out in some sort of structured object, and it did it. And I essentially said, in certain cases, this could get to like 80 to 90% accuracy at this point in time. And of course, you need to be mindful of like how much accuracy and the cost of failures there. But nevertheless, the question I got, which like sort of made me realize like, oh shoot, we're moving so fast, but like there are these companies and industries that are not moving as fast as us. And it's like we do have to be cognizant of where they are at as well. And the question this person posed was, how can I trust the LLM is extracting the right fields? It's a valid question. Obviously, we need to get the toolings to allow folks to do proper evaluation. And Chip already mentioned that evaluation is kind of getting messy within Gen AI. So that's one aspect. The second to me is about like the actual trust. Like if we're replacing systems that exist today that people have used in their workflows, there's a lot of change management here. There's a lot of buy-in that you're going to have to get. And so I think, at times when we are moving so fast, and like this is like the year of the agent, I think I've heard many times. And, some people just are like getting caught up with like, what's an LLM, right? And it's just like, how are you going to use an agent to automate the stuff that they are doing when they don't know what an LLM is and what it does, right? And so I think as, it's sort of on us, I think we bear a responsibility here, I believe, to build the tooling and whatever it is, the processes to help society, get trust within these Gen AI applications, especially as they become more powerful. Like I said, I don't think it's going to be a step function, but we'll need to provide tooling and processes to help people, not like us here, but folks who will be affected to trust these applications. So in summary, I think it's similar to what I've seen in the ML, but I think it's even to a heightened, like higher degree now, because LLMs and Gen AI are quite powerful systems. And with that, I think we're moving on to the breakout rooms. Do we still have time for breakout rooms, Chip, or how do you want to proceed here?
Given the time, maybe we can open the discussion here first. Anyone want to start? I saw a lot of discussion on Zoom. Well, are people shy? Okay, Philip, what's your thought?
Uh, yeah, so I think one of the biggest, like one of the most interesting things you talked about was kind of the black swan effect of AI, like basically how big of a deal, how one of the most important things for ML models and stuff is having a low cost of a wrong output. And that's what we were just talking about, the microwave and the AI surgeon and stuff. Like if you microwave something and it doesn't work, you get cold food, not a big deal, try again, warm it in the oven. But if your surgeon does surgery wrong, that's pretty, pretty serious negative cost, which can lead to some of the issues of trust.
I'm trying to do a poll on like whether 2024 is the year of agent. Wow, people are like pretty bullish. Nice. I'm actually pretty bullish about it as well.
Yeah, me
Cool.
too. There's still 4% that are, or actually, yeah, what is an AI agent? And I think we probably get more of that if this was opened up to folks that have not, dealing with ML, right, on a daily basis.
Maybe there should be an option like it's getting the it's starting up, right? They're not there, but we are. It's like inclination is coming, right?
So
Yeah.
what would be the applications for agents?
Personal assistant.
Okay.
Yeah.
I
Yeah. It's hard for me to look for something that I need right now, even in my system, right? This is like a starting point. And then, of course, in your daily life, then it will go.
One of the big issues with agents is we're products ourselves for advertisers, and so like an agent would be really good at grocery shopping for you. Like everyone's had the idea of ask ChatGPT to make a recipe and then get all the ingredients for that recipe. But if a human goes to a grocery store, they're going to buy a bunch of things they didn't plan on, and so there's a big marketing reason that agents won't be as effective because humans will probably end up spending more money at the grocery store. And I think that's going to be one of the issues with some like very easy wins for agents.
Yeah, also I felt like when people evaluate AIs, the expectation somehow is really high. So usually like when I'm sort of realize that sometimes when I get human expert, unless they are really good, I usually get frustrated a lot. So I feel like the amount of frustration I have with AI actually is less than the amount of frustration I have with like the random human experts that I find say on the internet.
Yeah.
So I'm so saw a comment on like just to type back to the discussions about evaluations. Elias, you have a really great point about setting up evaluation metrics from the get-go. You think you can share it?
Yeah, definitely. Yeah. I mean, that thought came to me like I have spent some time working as a software engineer. So like test-driven development is like the key thing, and then it's like something that's preached to be followed religiously. And I feel like that kind of mindset can be transferred to machine learning system design or even development, where you start with your evaluation metrics from the get-go and iterate to basically improve upon those metrics. And then, like someone mentioned, it may not be easy for online metrics because even if you have them figured out, it's really difficult to basically measure or reiterate based on those metrics. But what I feel is at least setting them up from the get-go would give you a really good starting point because you can work with other stakeholders to prepare for what you are going to even evaluate when you have things deployed in production. For example, what one example that I shared is, let's say you are working on a recommendation system that's going to be recommending videos. One of your online metrics might depend on having a like dislike button. So that kind of UI change is maybe some fundamental change that you need to do to your product. So those things need to be planned well ahead of time for things to work out well after you go live. So I feel like it applies both to offline and online metrics to have them from the get-go and then works to which basically transfers or relates very closely to what or how test-driven development works.
Yeah. I also found like somehow people are more lax with like generative AI evaluation today. I it's just like when I talk to people, even like really smart people. I was just say I was talking to the co-founder of like multi-billion-dollar startup. I was asking him like how do you evaluate the thing. He was like, oh, I have 5 prompts that I usually test. So it's just like people usually have a set of like pet prompts, so they just eyeball the results. I wonder if it's because of like there's more trust. It's like, oh, model is just like better now, and if it look okay, then I trust that it's okay, which is a very interesting behavior book. See this like there's a quote on like people don't wonder how microwaves works and they can still use it. I see that we are moving way closer to that nowadays, for AI.
Yeah, I think for generative AI, that's the biggest challenge, right? Like asking people to have a evaluation data set from the beginning is such an expensive proposition. And I'm talking about like, if you talk to customers and you talk to like people who are trying to build something, which are not like AI first or have dedicated budgets. So because just the notion that, okay, it's just working and it's super approximate, very hard to evaluate. And eval method discovery is also a challenge actually because for a lot of these natural language tasks, you still are discovering like how would you do it because you don't know how models were trained.
I also know that in the interest of time, I know that we schedule for like 11, but I think it would be good to have everyone have like break into a group. So I'm gonna set up a breakout room for maybe 10 minutes, and then we can meet back here, and then we can end the meeting. Oh, also, thank you, Group One. I think it's a really good conversations. I personally learned quite a bit, and I might or might not steal some of your ideas for my next book. But yeah, thank you.
Pleasure.
Yeah, I'm gonna start breakout room. Okay, so for on YouTube, we wouldn't be ending the live streaming now, but you can head out to our Discord if you want to continue the discussions. Thank you very much, everyone. So I'm gonna start with let participants choose room. Yeah. So please pick the number according to the group.
So we're just doing like open discussion. We're not going to go over some kind of test scenario case study.
Oh yes, you did prepare that, right? I can
Yeah.
broadcast it to people.
Thanks. Yeah, that's
Yeah,
my
thank
bad.
you.
I did a quick pivot there.
Sorry.
Okay, my bad.
I'm not sure if 10 minutes will be enough to discuss this, but it's fine.
Yeah. Let me broadcast you every group. What do you want about to discuss with the scenarios?
Yeah, it was kind of more like just a role play thing, just to see, just to tease out the general themes of chapter 1. But yeah, I don't know if we'll have time or they'll have time to go through it.
Okay.
But we could try, and if people can do it, cool. If not, then I'm sure they're going to have nice discussions anyways.
It's great.
So wait, Andre, did you want to introduce a scenario or?
Oh, I think Chip was going to broadcast it
okay.
already.
Yeah.
Okay.
There's some limitations on like how long the message we can broadcast. So I can't copy and paste the entire thing, sadly.
I can just screenshot it and then just post it
Okay.
into the group. Yeah.
Oh, okay.
Okay.
We can also have the Discord group. Yeah, that's a good thing.
Thanks, Vern.
Yeah, no problem.
So you ended the live